Hi everyone, today we're going to learn more about circle theorems. If you remember last week, we went over the theorems that are related to segments, but today we're going to cover theorems that are related to angles. Now, let's do a quick review of central angles and inscribed angles. Let's start with the central angles. A central angle is the angle that forms when two radii meet at the center of the circle. So, for example, in this circle, we have BAC is a central angle because the vertex of the angle is the same as the center of the circle. Remember that a vertex is the point where two lines meet to form an angle. So central angle's vertex will always be the center point of a circle. Now, the inscribed angle is the angle formed in the interior of a circle when two chords intersect on the circle. So this angle has a vertex on a circle and sides that contain chords of the circle. For example, in circle C, we have Q R S. This angle is an inscribed angle. We also have the arc QS. This arc is a minor arc that is intercepted by the angle QRS, and this arc called an intercepted arc, which has endpoints on the sides of an inscribed angle and lies in the interior of the inscribed angle. For the inscribed angles, we have three different types. So the first one, where the center is on a side of inscribed angle, so it's this one, and this side must that contains the center of the circle must be the diameter. So the second type is where the center is inside of the inscribed angle, and the third type we have the center is in the exterior of the inscribed angle. The first theorem we are going to cover today is the inscribed angle theorem. So this theorem says if an angle is inscribed in a circle, then the measure of the angle equals 1/2 the measure of each intercepted arc. So for example, in this circle we have the angle 1 is an inscribed angle. So the measure of angle 1 is equal to 1/2 the measure of the arc AB, which is the intercepted arc. And we can do an example of this theorem. So in this circle we have the measure of angle N is 56 degrees and the measure of arc MN is 70 degrees. So first let's find the measure of angle P. So we have P is an inscribed angle and its intercepted arc is MN, and according to the previous theorem the measure of angle P is 1/2 the measure of the arc MN, and if we do the substitution then we get measure of angle P is equal to 1/2 times 70, which is 35. Now let's solve for the measure of arc PO. So we have the arc PO is the intercepted arc of the inscribed angle N, and we have the measure of angle N is 56 degrees. So according to the theorem, then Since we have the measure of the angle is given, then the measure of the intercepted arc must be 2 times the measure of the inscribed angle. And if we do the substitution, then we get the measure of the intercepted arc PO is equal to 2 times the measure of the angle N, which is 56, and this can be simplified to 112. So the measure of the arc PO is 112. Now we're going over another theorem of the inscribed angles. So this theorem says if two inscribed angles of a circle intercept the same arc or congruent arcs, then the angles are congruent. So for example, in this circle we have the angle C, this one, and the angle B intercept the same arc AD. So according to the theorem, then since both inscribed angles intercept the same arc, then those angles are congruent. So the measure of angle B is equal to the measure of angle C. And this theorem also applies to the inscribed angles that intercept congruent arcs. For example, on this circle, let's say that angle X is an inscribed angle that intercepts this arc AB. So this one is X, and there is another. I know this one is not perfect, but I'm trying my best. Alright, and this angle Y is an inscribed angle that intercepts an arc CD, and let's say that arc AB is congruent to arc CD, so that means that the angle X is congruent to the angle Y. Now let's do an example of this theorem. So we have two inscribed angles T and U that intercept the same arc as V, and according to the previous theorem, since both both inscribed angles intercept the same arc, then these angles are congruent. So we have the measure of angle T is 3x minus 5 degrees, and the measure of angle U is 2x plus 15 degrees. So and we said those angles are congruent, therefore 3x minus 5 is equal to 2x plus 15. So if we do the substitution, then we should get x equal to 20. And since both angles are congruent, then we only need to solve for one angle. And for example, if we solve for the measure of angle T by plugging 20 to the x, then we should get 3 times 20 minus 5, and this can be simplified to 55. So then the measure of angle T is 55, and it's the same as the measure of angle U. Now we're going to cover some theorems about angles of inscribed polygons. So let's start with the triangles. So this theorem says an inscribed angle of triangle intercepts a diameter or semicircle if and only if the angle is right angle. So that means if one side of an inscribed triangle is the diameter, then the other two sides must form a right angle. For example, if FGH is a semicircle, then the measure of angle G is equal to 90 degrees. Now let's do an example of angles measures in inscribed triangles. So we have on this circle we have an inscribed triangle FGH, and now we can see that FH is a diameter of this circle, then FGH is an inscribed triangle in a semicircle. Therefore FGH is a right angle, so this triangle is a right triangle. So we have to solve for the measure F, we have the measure of angle F plus the measure of angle G plus the measure of angle H is equal to 180 degrees. So if we do the substitution, then we should get 4x plus 2 plus 90 plus 9x minus 3 is equal to 180 degrees. And if we simplify, then we get 13x plus 89 is equal to 180, and if we subtract 89 from each side, then we get 13x equals 91, and by dividing by 13, then we get x equal to 7. Now to solve for the measure of angle F, we just need to plug in 7 to the x of 4x plus 2. Then we get 4 times 7 plus 2 equal to 30 degrees. So the measure of angle F is 30 degrees. The next theorem is about the angles of inscribed quadrilateral, and I think that is something that Miss Laura had covered in her last week video, but we can go very quick over this theorem. So it says that if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. For example, in this circle A, we have an inscribed quadrilateral KLMN. So let's say that the measure of angle K is 110 degrees, and the measure of angle L is let's say is 80 degrees. So we know that the measure of angle K, according to the theorem, the measure of angle K plus the measure of angle M is 180 degrees. So then the measure of angle M is equal to 180 minus the measure of angle K, so which is 180 minus 100, and that is equal to 70 degrees. So the measure of angle M is 70 degrees. So we're going to do the same thing to solve for the measure of angle N. So since angle L and angle N are supplementary, then the measure of angle L plus the measure of angle N is equal to 180 degrees. Then if we want to solve for the measure of angle N, so we just need to subtract the measure of angle L from 180, and that's equal to 180 minus 80, and this is 100 degrees. So the measure of angle N is 100 degrees. The next theorem we're going to cover says if two secants or chords intersect in the interior of a circle, then the measure of an angle formed is 1/2 the sum of the measure of the arcs intercepted by the angle and its vertical angle. So, for example, in this circle, we have two chords AC and BD, and they are intersecting at this point, this one right here. Now for angle 1 we have its intercepted arc is AB, and its vertical angle is this one. So then DC must be the intercepted arc of the vertical angle of 1. And according to the theorem, the measure of angle 1 is 1/2 the measure of the intercepted arc AB plus the measure of the intercepted arc CD. So notice that AB is the intercepted arc of the angle 1, and CD is the intercepted arc of its vertical angle. And we do the same thing to find the measure of angle 2. So we have BC is the intercepted arc of angle 2, and AD is the intercepted arc of its vertical angle. So then the measure of angle 2 is 1/2 times the measure of the arc DA plus the measure of the arc BC. Now let's do an example of using intersecting chords. So in this example we have this circle, and we also have two intersecting chords, TS and RU, right? So we have the arc measured. So the measure of the arc TU is 130 degrees, and the measure of the arc RS is 84 degrees, and we are looking for the value of X, which is the measure of the angle TVU. Now we have TU is the intercepted arc of the angle TVU, and we have the arc RS is the intercepted arc of its vertical angle. So according to the previous theorem, we have the measure of the angle TVU is equal to 1/2 the measure of the arc RS plus the measure of the arc TU. And if we do the substitution, then we should get X equal to 1/2, it's equal to 1/2 times 84 plus 130. Then if we simplify, then we should get 107 degrees for X, which is the measure of the angle TVU. So the next theorem says if a secant and a tangent intersect at the point of tangency, then the measure of each angle formed is 1/2 the measure of each intercepted arc. For example, in this circle we have this secant line, this one, intersect this tangent line at point A. So we also have AB. This arc is the intercepted arc of angle 1, and AB is the intercepted arc of angle 2. So according to the theorem, the measure of angle 1 is 1/2 the measure of its intercepted arc AB, and the measure of angle 2 is 1/2 the measure of the arc ACB. Now let's do an example of intersecting secants and tangents theorem. So on this circle, we have a secant line. A secant line intersect this tangent line. So, and then we have the measure of the arc PQ is 148 degrees. According to the previous theorem, then the measure of the angle QPR is equal to 1/2 the measure of each intercepted arc PR. And then if we do the substitution, then we should get 1/2 times 148 for the measure of the angle QPR, which can be simplified to 74. And we can do the same thing for the other on the other circle. So we have a chord or a secant line that intersects a tangent line. So the measure, and then we have the measure of the angle FDC is 64 degrees. So then the measure of each intercepted arc FD must so 1/2 of each intercepted arc FD must be equal to 64 degrees. So then if we multiply both sides by 2, then we should get the measure of the arc FD is equal to 128 degrees. So the next theorem says if two secants, a secant and a tangent, or two tangents intersect in the exterior of a circle, then the measure of the angle formed is 1/2 the difference of the measures of the intercepted arcs. So in this theorem we have three different cases. So in the first case, so we have two secants that intersect in the exterior of the circle. So then we have the intercepted arcs are AB and DE. So according to the theorem, then the measure of angle A is equal to 1/2 the measure of the arc DE minus the measure of the arc BC. Now, in case 2, we have a secant line intersects a tangent line. So this secant line, and this is the tangent line, and the intersection point is in the exterior of the circle. And according to the theorem, then the measure of the angle A is equal to 1/2 the measure of the intercepted arc DC minus the measure of the intercepted arc BC. Now in the third case, we have two tangents intersect in the exterior of the circle at point A. So the measure of angle A then is 1/2 times the measure of the intercepted arc BDC and minus the measure of the intercepted arc BC. Now let's do an example of using tangents and secants that intersect outside the circle. So in this circle we have two tangent lines intersecting in the outside of this circle at point L. So according to the previous theorem, then the measure of the angle L is 1/2 times the measure of the intercepted arc HGK minus the measure of the intercepted arc HK. We also have the measure of the intercepted arc HK. This one is 102 degrees. Therefore, the measure of the arc HGK must be 360 minus 102. Now, if we do the substitution, then we should get the measure L is equal to 1/2 times 360 minus 102 minus 102. Then if we simplify, then we should get 78 degrees for angle L. Then we can do the same thing to find the measure of the arc CD. and the other example. Now this table summarizes the circle and angle relationships. So if the vertex of an angle is on the circle, so then like these two circles right here, then the measure of the angle is 1/2 of the measure of the intercepted arc. And if the vertex of the angle is inside of the circle, like this one, like this circle right here, then the measure of this angle 1 is 1/2 the measure of the sum of the intercepted arc. So that means the measure of arc of angle 1 is 1/2 times x plus y. Notice that y is the intercepted arc of angle 1 and x is the intercepted arc of its vertical angle. Now the third case is when the vertex of the angle is outside of the circle. So we have three different situations. So we can have the intersection of two secant lines, or the intersection of two tangent lines, or the intersection of one secant and one tangent. And then the angle measure is 1/2 of the measure of the difference of the intercepted arcs. So in this example we have the measure of angle 1 is 1/2 times x minus y.